Hello everyone. We are looking at phase 3, chapter complex number, exercise 1, and we are question number 6. So this is a simple question again, but the reason is we have to just recall the polar form, how to express the complex number in the code. Polar form. So polar form, just to recall, if our complex number is a plus ib, then r into e to the power I theta, where r is the mod and theta is the argument of the complex number. So I'm not going to go into detail how to express it as a plus ib because we have done questions like this. So let us look at, borrow it from the example here, solution here. So this will become minus 1 plus I. And then we have to write it in this form. This is the polar form. This is the exponent form. Okay, this is the exponent form. Polar form is r cos theta plus I sin theta, where again r is the mod and theta is the argument. Theta is the argument and r is the mod. So what I had written earlier was the Euler form. But doesn't matter, both of them, they go into each other. So now how do we find r? If this is a, this is b, then r is a square plus b square root over. So we can see it is 1 plus 1. So r is equal to root 2. Now, what is the argument here? So for argument, first we find alpha as b by a. So tan alpha. The process is set. First of all, we find the mod of b and a, and we find out that this is nothing but 1. So it is pi by 4. Now, which quadrant? Second is we decide the quadrant. So alpha is equal to pi by 4. Now, which quadrant it is lying in? If this is x, this is y, then x is minus, y is positive, then it is in the second quadrant. If it is in the second quadrant, then the argument is pi minus alpha, which is pi minus pi by 4. So 3 pi by 4. So this is nothing but 3 pi by 4. So cos 3 pi by 4 plus I sine 3 pi by 4. So the process is simple to find argument. First of all, find for mod b by a or mod y by x. If we write it as x plus y, it is better because we can immediately connect with the x and y axis. So this is y by x. So if y by x is 1, so r is equal to a square plus, x square plus y square. It is just a mental thing. So r is equal to x square plus y square. So we get this as root 2. And tan alpha is y by x, which is 1. So alpha must be pi by 4. Now we have to first decide which quadrant it is. Just look at the signs of y and x. Y is positive, x is negative. So it will be in the second quadrant. If it is in the second, then it is pi minus. Here theta is equal to alpha. Here theta is equal to this. Here theta is equal to minus pi plus alpha, and here it is minus alpha. Theta is equal to. So if we just remember this table and this concept, we can easily comment on the argument. So this is our polar form. If it was asked to comment the same thing in the Euler form, it is very simple. R we already know, root 2 e to the power I, and the argument we found was 3 pi by 4. That's it. This is the Euler form. This is the polar. All right. Thank you.